Assalamualaikum warahmatullahi wabarakatuh. So now we'll be presenting about our mini project that we call as Shoboshi firefighting robot. Before we proceed to the presentation, let me introduce you to my teammate. My name is Muhammad NAQIB FARIS and my team consists of Abdul Hakim bin Kamal BASHA and HASYIMAH binti ROSLI.
Assalamualaikum, my name is HASYIMAH and I will be presenting objective of this mini project. We have three main objectives, which is to study the concept of coding and programming using Tinkercad simulation. Next, to build and create a customized mechanical robot design that are autonomous, functionable and durable. Lastly, to study the prediction of robot movement and feedback when using sensor when detecting obstacles and fire. Problem statements from this mini project have three, which is fire, risk and smoke. We know that fire is a natural disaster and smoke occurs when fire is produced, which is bad for human lungs. So we have to minimize the risk of trapping inside a building or loss of life. The solution that we can obtain is we can create an autonomous robot that are self-navigated, which we will be programming to make the robot distinguish between clear path and obstructed pathway.
Let's continue to the flowchart and the condition table. For the condition table, we have set few conditions for the movement of the robot and the action of the water pump. IR sensor will be placed at the left and the right side of the robot. The input that was received from the IR sensor will determine the movement of the robot. We set the IR sensor value as 0 if there is obstacles or wall at the side of the robot and 1 if it detects no obstacles or walls. As an example, when there is wall that is located at the left and the right side, which is more than 25 cm, both IR will give input of 0 and the robot will move forward. However, when there is no wall at the left side of the robot, the left IR sensor will give input of 1, thus stopping the DC motor for the left tire and the robot will turn to the left because the input of the right sensor is still 0 and the tire is still moving. For the action of water pump, this involves ultrasonic sensor. When ultrasonic sensor detects no obstacles or fire on his pathway, the water pump is in off state and it will move forward. But when electronic sensor detects an obstacle or fire less than 25 cm and the temperature is more than 110 degrees Celsius, the robot will stop and water will be pumped out using the water pump. The flowchart will explain about the movement of the robot and the water pump.
Next, I will be presenting the 3D design of our robot. For the front view, we have included water pump, ultrasonic sensor, both IR sensor, Arduino board, temperature sensor, and from the side we can see our driver wheel and steer wheels. For the back of our 3D design, we have the battery that supported 9 volts, our motor driver, water tank, and from the bottom you can see that we have used our motor gear, both right and left side. This is the overview of our 3D design.
Assalamualaikum, my name is Abdul Hakim. Okay, next we are moving to the circuit diagram and also coding that we are using for our robot, which is Shoboshi. Now we start the circuit. When I set the circuit, the obstacle far from the ultrasonic, and you can see that the left and right motor are moving forward. And if I set the left photoresistor from the white line, and okay, the robot will turn left, so the left motor will move slower than the right motor. And when I set it back, and when the right photoresistor found the line, white line, so the robot will turn to the right and the right motor will move slower than the left motor. So what happened when both photoresistor found the white line? The robot will stop. Alright, both motor are 0 RPM, not moving. Okay, when I set it back, the robot will move forward. So next is when I set the obstacle is below 25 centimeters. Okay, what happened? The robot will stop. Both motor are 0 RPM. And what happened when the left photoresistor found the white light? Okay, the motor will turn left. So the left motor is slower than the right motor. So when the right photoresistor found the white line, the robot will turn to right. So the left motor is higher speed than the right motor. Okay, so when both photoresistor found the black line, the robot will stop. As you know, the DC motor is replacing the water pump. So when the robot detecting object with lower temperature, the water pump will stop 0 RPM. And if the robot detecting object with high temperature, okay, the water pump will moving and then the robot will detecting fire. Okay, we are replacing the photoresistor with the IR sensor because in this Tinkercad the IR sensor cannot be used, and then we replace it with photoresistor. That's all for the diagram. Let's move to the coding. Okay, for the coding from 1 to 11, we used to declare the variable that we are using in this coding. Next, we are using the void setup command, and then the serial begin. Next is to declare all the pins that we are using. Okay. Next, using the void loop. Okay, by using this void loop, we are able to state the condition and the function for the robot, which is electrical. This is for ultrasonic sensors. This is the formula to calculate temperature. This is the formula to calculate the distance the robot between the obstacles. Then the formula for photoresistor sensors. Next is the coding when the distance between robot and the obstacle is less than 25 centimeters. Okay. At this part is the coding for water pump off, water pump on. Water pump will off when the temperature is less than 110 degrees Celsius, and water pump will on when the temperature is more than 110 degrees Celsius. Next is the coding for the robot when the distance between the robot and the obstacle is more than 25 centimeters. Is all the direction to move forward, to stop, to turn left and turn right. And lastly is the command for the robot to have the movement. First is void move forward. We declare all the pin and the speed for the motor. To turn right, when they turn right, the left motor will be higher than the right motor. And when to turn left, the right motor will faster than the left motor. And then lastly is void stop for the robot to stop, which is both motor are at 0. Okay, that's all from me. Thank you.
We have found 2 improvements that we can use to improve our robot. First is to check the condition to ensure that it meets the standard set by means of programming and coding. This is because to get a good result, we need to keep the robot is in good state and there is no flaw in the programming or the coding of the robot. The second one is to use durable material that can withstand the heat of fire so that it can operate well. This is because in the robot we have Arduino Uno, we have IR sensor, and we have ultrasonic sensor. So we need a good material to build up the robot so that it can protect those components and the robot can operate well and do its task. So we have reached to our conclusion. There is 3 conclusions that have been made for this project, which is the first one is with proper build-up and coding, autonomous robot can be used to replace human to do dangerous work such as putting out fire in a building. The ultrasonic sensor and the IR sensor that are the most important parts for the robot autonomous system. And the third is from the 3D design, the flowchart, the circuit design, and the coding that we propose. We believe that Shoboshi, our robot, will achieve its objectives and do a very excellent job to complete its task. Thank you.